Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight I'm excited to bring to you Accelerating Student Learning. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight we're joined by a bunch of people, more than our usual. We have with us Sherry Abel, Margaret Bambrick, and Dan Alaria. So Sherry has completed more than 35 years in education and is currently spending her time consulting. She taught middle and high school math for 28 years, including Algebra 1, Geometry, Algebra 2, Pre-Calculus, Calculus, and AP Statistics, and has been a state transformation coach, as well as a district high school math specialist. So only a couple hats that she's worn in the past there. Her passions include helping other teachers see the power in having students explore mathematics concepts through the use of technology, as well as helping students make connections between math and the real world. So Sherry, it's great to have you with us tonight.
Glad to be here.
And Margaret lives in DeLand, Florida, where she served in Volusia County Schools as a 9 through 12 mathematics teacher, math coach, and math specialist for over 30 years. She continues to be involved in math education and serves on the board for FCTM. She was recognized in 2019 as the Kenneth P. Kidd Mathematics Educator of the Year in Florida. And as a T-Cube National Instructor, she has fostered her lifelong love of learning by serving on several writing teams, such as Algebra-Inspired and other PD offerings. She currently specializes in professional development for mathematics teachers and uses the instructional technology to support students' learning and serves as a T-Cubed systemic coach. So Margaret, we're excited to have you with us tonight.
Here.
And Dan is also a T-Cube National Instructor as well as Professor of Mathematics Education at West Chester University of Pennsylvania. Dan's taught middle and high school mathematics as well as been a supervisor of mathematics for several school districts in New Jersey. Currently, he uses TI technology with pre-service and in-service teachers as part of a pedagogy class at both the undergraduate and graduate levels. So Dan, we're also excited to have you with us tonight.
Thanks, great to be here.
Tonight we're going to do some really exciting stuff. We obviously are currently working on the welcome and introductions, and then we're going to think about, well, do any of your students suffer learning loss? Guilty. And then we're going to talk about some classroom strategies of what can we do if your students are coming to you with some learning loss. We'll end tonight looking at some professional development resources and have a webinar drawing at the end, so make sure you stick around. One lucky winner is going to receive a T-Cubed International Conference registration. We'll be using the chat window a lot tonight to send general messages. Feel free to send any questions to any of the four of us using the Q&A window on the right side of your screen. As a reminder, the session is being recorded, and we'll provide a link the event certificate of attendance at the conclusion of the webinar. All right, Dan, will you kick us off?
Certainly. Good evening, everybody. Glad to have you here. So we want to start our evening with this problem of practice. We kind of alluded to it in our agenda. Feel free to add this in the chat. How many of you have come across this situation where students are working on a task in class and all of a sudden there's just some piece of knowledge or some skill that they should have learned before and they just don't have it, and they're not able to complete the work? I know we had Mike raise his hand there before of yes, guilty as charged. And we're seeing everyone say, too often, and yes, absolutely. And we've all experienced this over the past year with the shift in the way we've had to teach students. So it's definitely exacerbated the problem, but it's certainly not something that is new to all of us. We just have kind of a bigger shoes to fill in terms of helping our students. So we have a couple discussion questions for you here. So think about how common this practice is. And Mike, let's bring up kind of our first question. How do you know students are struggling? Feel free to share in the chat the strategies you use. And I'm going to throw this one to Sherry to start us off, to share some, things that she saw that told her students were struggling.
Gosh, Dan, it was a plethora of things. Anytime I would start something in my classroom, a new topic, and you would start teaching and you could see the blank stares on faces, that was one clue that they weren't all quite with me. But I could throw something out there to my students to try, and I could see them getting stuck at the very top of the problem, on the easiest part of the problem where they should have been fully engaged, on the things that they should have already come to me knowing. And I know we say it all the time, they should come to us knowing. I taught high school integers and fractions and decimals, and they're stopped right here and they can't do it. So I could see immediately when students were just hung up right there. They couldn't get to the meat of the problem because they couldn't get past the beginning parts because they were stuck on the past. So just the blank stares would be the one thing. Not being able to move past the initial point would be another. Just quick things, little checks at the beginning to know that they couldn't do the work.
Yeah, we're seeing a lot of that from the people in the chat in terms of students just sitting there, from Tracy and Elizabeth sharing they can't start the task, or lack of engagement. Um, and so Sarah just chimed in like questions at the beginning of the problem. So Mike, I'm going to throw this second one to you. And, as you're going through your curriculum, like what is your determining factor? And everyone who's joined us tonight can also share that around, what determines if the prior knowledge that kids seem to be missing needs to be mastered before the new material?
That's a really great question. I think sometimes that answer isn't super super clear. I think sometimes I've thought things need to be mastered, and maybe they didn't. I actually I shared this with you guys before we started tonight. The girl that teaches math right next door to me, I walked in and her and I were talking today about where she's at in Algebra 2. This is her first year teaching it. I've been teaching it for like the past 16 years. And she told me kind of where she was at. I was like, well, I'm kind of surprised. Like that you're not as far as I thought you'd be. And she's like, oh, well, I had to spend the first like 3 months doing Algebra 1 because they weren't ready. And so, I don't know. I don't know if that was the best use of the first 3 months of their Algebra 2 time. So I would say in general, I don't know too many topics that really need to be completely mastered before students are trying to do something at maybe grade level, because so much of mathematics, right, it keeps on coming back, and it's very cyclical.
Yeah, that's a good point, right? We have a lot of opportunities for application of concepts that were learned earlier on, instead of like teaching for mastery. And I saw someone in the chat just mentioned kids go, they've never seen this before, when really they worked on it for like an entire month 2 years ago. They just don't remember anything. And obviously, the lack of learning opportunities these past 2 years has certainly made that worse. So we want to talk tonight about a strategy for addressing this particular challenge. And so there's a couple ways to attack this. There's the one that your teacher mentioned. But if we look at a different approach, if you can share the next slide, we've got this idea of just-in-time review. Is been shown to be much more preferable and beneficial to students rather than repeating material from the year before. And so we want those skills that kids need with the grade level content to be refreshed, reminded, kind of a quick hit review, just as kids need it, because then they're just going to apply it. So they see the application, they see the use of it. And you mentioned about textbooks. And if a lot of us out here have those kind of traditional textbooks where we're doing a lot of the curriculum work because it's very skill heavy, those textbooks have all this kind of redundant material in it. And so I remember that from teaching 7th grade or 8th grade pre-algebra and algebra. It was like the two books were pretty much the same thing. They maybe just had different levels of problems in it. So we want to take a look tonight, and we picked a couple of topics that we think are, pretty broad across mathematics courses to talk about what are these knowledge and skills that kids need to be successful, and how might we kind of throw that in right at the beginning of a lesson so we can still teach the grade level content. So from that perspective, that's what we mean by accelerating student learning, because we're getting those multiple grade levels in order to all at the same time, right? So we order to catch up. So rather than kind of teach the review in isolation and then kids forget it, we teach it just when they need to use it so they can apply it and they'll remember it better. And that's what a lot of the research shows. So let's look at our first topic for tonight. We'll get us started. So here's a lesson goal. I can solve a system of equations using elimination. And I picked a system here that maybe we want students to answer by the end of this class. So let's get some feedback from the audience. What are some prerequisite skills or knowledge needed to achieve the goal of being able to solve system by elimination, right? So Margaret, what's some prerequisite skills or knowledge that come to mind for you while we wait for people from the audience?
Well, they have to be able to work with multiplying integers and understanding how to, well, first of all, what a system is. They have to be able to combine like terms. Let's see, I see in the chat inverse operations out there.
Mm-hmm. Yep, I saw combine like terms too.
Noticing
Emily's making a good
structure.
point. Yep, noticing structure, that's a great one, right? A lot of like work with adding integers, because if they're going to combine like terms, they have to work with those coefficients. Sharon
Sure.
just shared in distributive property. Like those are some really good options, the things that make it possible for kids to do that. And like we've shared, right, kids may not have got a lot of practice working with integers a couple years ago, and so maybe they're struggling with that. Students may, have done really well on the distributed property couple of lessons, but since you've left that unit, kids seem to continually be struggling with some of the common errors with distributive property. So let's talk about adjusting instruction here. How can we still teach this topic of systems of equations and solving it by elimination without having to take 2 days to go over, like maybe 1 day of operations with integers and try and do something real quick, and then maybe do something with distributive property and teach all of this other prerequisite stuff kind of separate? How can we kind of build that in? So our question, if we look at our adjusting instruction slide, is so it might give us a one slide forward, and how can you start a lesson to review the prerequisite knowledge and skills for success with the grade level content? So ideally, if we weren't doing this in a workshop, we'd do something where we kind of find out this information before we teach the unit, so we can plan ahead for where students might struggle. But for now, we'll just think about this. We had some good options out there. How can I change my warm up? Maybe my 5-minute warm up. How can we change that to include some of these prerequisite skills that students might need? So Mike, how about while we get some suggestions from some people about what they think they might do, I want to pop over and share my Nspire software with everybody. And share a couple ideas that I came up with, and this might help with sparking some ideas from people in the audience. So here would be my warm-up. So hopefully we've got, everyone can see my Nspire software. So I threw a little math talk together. And so,
Dan, hang tight just 1 second.
Sure.
Mike, they are not seeing slides for some reason.
Yeah, I got them. They're okay on my end.
Okay, thank you. All right.
Yep.
Sorry,
if anyone's
Dan.
having any technical issues, if things don't kind of clear up quickly, then just know that you'll automatically get a follow-up recording with a link in your email for the recording and the documents and the certificate as well.
Sounds good. All right, so so in thinking about how I might start a lesson where I'm going to teach systems of equations by elimination, I might start out with a math talk because I know kids are going to have to combine like terms. And so I might do this to get started and ask kids, so one at a time, how would you simplify the expression that you see? And how did you get that, right? So we get a little review in here. If I have a nice CAS system, I might start with a calculator page and maybe put some of these systems in here and hit return and ask kids, how did the calculator get that? That could be a different approach, So there was the first one from my math talk. I can paste in the second one from my math talk, hit enter, what would happen, right? And ask kids what's going on and have a short discussion, 5-7 minutes at the beginning of class, just to bring these ideas back. I could start off something like this and be like, so make a prediction, right? What do we think it might be? How do you know? Almost like I'm asking them to simplify, and then I can hit enter and get a result. We could have all these up. What are we seeing? What patterns are we seeing? How is this working, sort of thing. And so it's a quick way to get students to have a conversation about how to combine like terms, maybe remember some things from, when they started combining like terms back in 7th grade, even though we're in an algebra class. Another possibility is using a building concepts file. There's one from the website in the building concepts material about building expressions in 2 variables. And so you could have students jump over to this page and create 2 different expressions. Have them create their own, bring in some operations here, and ask them to, maybe we start with this one and say, can you write this in a different way that uses more than one term with the A's and more than one term with the B's? And so kids are kind of thinking of their own way of, how do I combine like terms? What am I looking for? What do I have to pay attention to? That would be an ideal way to get students to just think about that concept, because what are they going to end up doing in this lesson? They're going to end up adding X's together. They're going to end up adding up Y's together. We want to make sure they could do that properly. So I'm going to turn it back over to you, Mike, for control. And let's see, what else did people share in the chat? Doug mentioned like doing some multiple choice with preconceived errors to identify shortcomings. I think that's one of the things that would ideally, in a perfect world, right, we would all be able to do that before we start a unit, so we can see where students are going to run into issues, and we can make those plans ahead of time. But if we don't, that's a good strategy, right?
Dan, can I just pause for 1 sec? So I just want to make sure, because I think we just kind of glossed over something real quick. So you were just talking about that would be something great to do at like the beginning of a unit, right? And we were just showing something that was like one specific, part of a unit that you might be teaching, right? So I don't. Can you kind of clarify that? So like, would you want to possibly do that suggestion that Doug had, using like a multiple choice with some preconceived errors every single time that you're about to teach something like solving systems of equations or, whatever whatever content you might be teaching that day? Or is that something that you suggest using at like kind of the bigger level whenever you're about to teach a unit?
Yeah, so I think ideally, whenever we're about to start a new unit, we get some information about what our students know about the supporting content knowledge that's going to be in this entire unit. And if we can do that, then we get like a preview of where students might struggle. And so that's kind of like at a unit level. For a particular lesson, like we looking at now for like, we're going to do this particular lesson on solving systems of equations. So a prerequisite skill we may need to review is combining like terms. And so we can do a warm-up math talk. We could do something where, kids maybe chat about how to combine some like term problems like Sharon is suggesting to start the lesson off to make sure that particular skill is nice and fresh before we get to that grade level content around using elimination to solve a system of equations. Does that clear it up? All right. Okay, so let's turn it over. Let's take a look at a second topic. And Margaret, you're going to take on this topic, right?
Okay, sure. This topic is about using the Pythagorean theorem to find missing sides of right triangles. What kinds of prerequisite skills and knowledge is needed to achieve the goal? Go ahead in the chat and kind of throw some things out there after you take a moment to read the task and think about the goal, the lesson goal. One of the things that I think of right away has to do with being able to identify right triangles. Another thing is recognizing perfect squares, dealing with square roots. Mike, what are you seeing people bring up out there?
We're seeing some really good stuff. I saw like working with exponents and make sure they can handle square roots. The one I liked came from City, and I think I saw another person that had something similar, maybe Emily, was just being able to set up the problem. So like just understanding the problem, because sometimes these Pythagorean theorem problems aren't just kind of a straightforward math problem. Sometimes they involve a little more information, and so can students take, a few sentences and pull from that and draw a picture and set the problem up correctly?
Sure, using some of their strategies, maybe underlining, and the figure for sure. One of the things that we could do just using, we could work on perfect squares and being sure they're have their perfect square table out there, just on the home screen of the either calculator, but I'll go with the Nspire. Let me share my screen or share. Yeah. There we go.
Sorry, Margaret, you should have control now.
Okay.
Now try and share.
Okay.
Yeah, while you're getting that set up, I think some of these suggestions just around students being able to identify and what's the hypotenuse and what's a leg, and this way they can connect that to the situation, is a really great suggestion, right? So how do you, if that's something that you're seeing students struggle with, how do you start your lesson off in order to make sure kids can identify hypotenuse, can identify legs in a triangle?
And with that, I think as you explore further, you're going to find some assistance with some files that are made up. But I'm going to just start with, since Dan's taken me there, but I'm frozen right now. Okay, so I'm going to just kind of start with looking at our perfect squares. And so taking the square root of perfect squares, the square root of 1, the square root of the next perfect square, 4, the square root of 9. The square root of 16. Whoops. Hello. So if I was doing this with my students, what we could ask, what do you notice? What do you wonder about the square roots that I have on the screen and their table that hopefully they have, with enough practice, start understanding about those perfect squares? Can you send something in the chat? What do you notice? What do you wonder?
Well, Margaret, just to help out, I would say that I would begin to notice that, like, I could see that the square root of 16 is 4, and 4 times 4 is 16. And then I noticed that, well, gosh, that works for the 3 too. So 3 times 3 is 9, and 2 times 2 is 4, and it keeps working. So 1 times 1 is 1. So I'm going to think that then the square root of 25 must be 5, because 5 times 5 is 25, and that must continue to work that way. So if I get to the square root of 100, it must be 10, because I know that 10 times 10 is also 100, right? So I can kind of see how that pattern begins to flow.
Okay. Dan, what
So
are some other, I'm sorry, Mike, you were going to speak up?
Yeah, I was just going to ask a quick question, and this is for Margaret or Sherry or Dan, whoever wants to take it and run. So let's say that you address your prerequisite knowledge, and we recognize that students need help with simplifying square roots. And you go through your kind of mini lesson, and so then are you reassessing them after this to make sure that they are good to go? Do we just assume, hey, we covered it again for these 5 or 10 minutes, we should be good to go with grade level content? Like once we do this kind of intervention, where do we go from there?
Well, one of the things I was going to say is I would get my students to talk about what tools will help them as they're working on these types of problems. And it might be making a table of the perfect squares, and then investigating putting different numbers in the Pythagorean theorem and working with that a little bit, just experimenting. I like to have students talk and give each other ideas, work in small groups, and do some formative assessment as I'm going around and looking to see either what they're writing down on. We use the desk as a whiteboard, or did quite a bit, as well as I also pulled things up. I happen to use the navigator system in my classroom too for that.
I think that anytime you're doing a mini lesson like this is not a one-stop deal. It's not a one-stop shop. In other words, this is a brief mini lesson. It gets us started so we can dive into the grade level content. And we have to keep this as a cycling through. We're going to continually hit this content as we're working through grade level problems using Pythagorean theorem. So they're going to get re-exposed to this content over and over and over again as more and more practice. So they're going to get this content again, square root, practicing these perfect squares, but also getting practice with those that are not perfect and how to handle those things that aren't perfect.
And ideally, we've now done this, and kids have noticed some patterns. We remind them of what a perfect square is and how that works, and we say to students, all right, we are going to talk about a new topic today, and so you are going to use these square roots at some point in the rest of this lesson. So let's keep them available on a piece of paper, or let's leave them written on the board. And so when you run across something like this, I want you to refer back to it. And now let's, transition into our grade level content, where kids are going to apply what they just learned. Hey, we might not get all the kids, right? I wouldn't expect from this kids to be all of a sudden masters with square roots, but we might get a couple kids who remember something that they did, and then we don't need to help them. We can focus maybe with some other kids, or we can now determine if kids are getting stuck with something like this material or the concept that's the objective for the lesson, because that's a big difference on how we address that.
Absolutely.
I think so. Any other items in the chat that we wanted to bring up? I don't have the chat in my window right now, so if somebody, any other things out there that some of our participants have had added?
There was some good notice and wonder. Someone noticed that both the values were going up in terms of what we were putting under the square root and what the results are.
Okay.
You know, and then talking about, you know, how students might be able to, even though we might not talk about it with this, if they need to, in, let's say, the problem that we were talking about with having to solve using the Pythagorean theorem, they might be able to estimate a square root value because we have this table, because the numbers in between are not perfect squares, right? The ones that we're using. So some good suggestions from everybody out there.
Great. All right. So go ahead to the next slide, adjusting instruction. I think we've talked about this already, Mike. I'm gonna pass it back to you for a moment. Maybe. There we go. Oh, you got it. Thank you.
Yep.
So I think we're ready for topic 3. We got some good suggestions about how we can start that lesson.
Okay.
All right, ready? Sure.
Yeah, this is me. So we're going to move into something that we all know and love, and that our students just know and love as well, which is using unit rates to write equations to model proportional relationships. So that's a loaded topic all in one thing: unit rate, writing equations, modeling proportional relationships. So huge topic. So I want you to think, Jim just put ugh in there. Right, Jim? I feel you on that one. So throw in the chat, what are the prerequisite skills and or knowledge that you believe are needed to help achieve this goal? All right, some people are saying we just got done teaching this unit. Some are saying independent and dependent variables, proportions, unit analysis, understanding a ratio is just a fraction, unit cancellation, ratios, thinking about units, fractions and proportions, simplifying. Okay, so we've got some really great ideas out there. Okay, a constant of proportionality. So we all have some ideas about this, and I believe that we're all on the right track. We know that we've got to really kind of narrow down to starting with what is a unit per one. Sharon, you nailed it, right? In the simplest of all terms, what is a unit? So Mike, if you'll flip to that next slide, is how can we actually start this lesson if we're going to review this prerequisite knowledge and skills? So what I did is we looked for something that was going to kind of harness this in maybe a new way, kind of a way that students may not have seen this presented before, because oftentimes we try to present this in, gosh, I'm just going to say it, guys, in the most boring way possible just to get through it so we can say we did it and be done with it, because it's the toughest unit ever and we just want to go and get done and move on, right? So this is a way to get at this to help students visualize what a unit rate actually is. So Mike, if you'll throw it back over to Margaret, I'm going to have her present this, and we're going to talk through what this is going to look like from a student point of view. So when we're looking at a unit rate, we want to help students understand what Sharon said. What does that mean? What does that unit mean, that per one mean? So I'm seeing, so determine the cost for one golf tee. And some people are like, my kids don't know what a golf tee is, right? So if we'll go to page 1.3, Margaret, for me, we'll jump right to the chase here. So golf tees don't make a lot of sense to kids, but guess what? They do know what a dog is. And you can even ask them if they have one, right? Or if they even want one. So a lot of kids will have an answer to that, I'm sure, or a story about how they got bit by one. And dog food. So they know that they have to take care of their pets. So this already has a hook for most kids out there. So what we're going to do is take a look at what we have right now. So right now we have the number of dogs at 2 dogs, and we have the number of bags of dog food set at 4. So right now, if we look at it, if I wanted to share that dog food between dogs, I could give right now each dog 2 bags of dog food, correct? So Margaret, could you just go ahead and slide those dog food bags over to show that each dog would get 2 bags of dog food? Okay, so now what we're looking at is each dog gets 2 bags of food, so 2 bags per dog. So we're getting at that unit rate. So let's reset that, Margaret. And this time, what we want to do is I want to look at a half bag. I want to look at 4 bags, 4 dogs, sorry. So increase my number of dogs to 4 dogs. And I want each dog to only get half a bag of dog food. So to do that, I have to think about now, how many bags of dog food would I need if I only want each dog to receive half a bag? Well, if each dog only receives half a bag, I would only need 2 bags of dog food. So each dog would receive half a bag. So I would reduce my number of bags to 2 bags. And I would hit that left arrow beside the number 1, or right arrow, sorry, to reduce to a half a bag. And now I could actually separate those to each of those dogs. So now each dog is going to receive half a bag of dog food. So again, getting at the notion of half a bag per dog. So every dog is getting half a bag of dog food, getting at that unit rate. So I see in the chat somebody said there are proportional relationships out there in life, like a person's body or face, and you are absolutely right. In fact, at the NCTM Regional, we just collected data using that. Height and arm span is a proportional relationship. It's a 1-to-1. You can actually do arm length and foot length and wrist and head and all these things that are proportional and collect real data to actually get at these unit rates. So you can do proportional reasoning with your kids in many unique ways, but this is a way to get at it where your kids can actually work together and explore this. And the beautiful thing is it's already there with the worksheet built in that you can edit if you need to. So getting at this unit rate is imperative if they're going to be able to write the equation in order to solve what they're going to solve for these problems. Look, in teaching chemistry, Barry says we use proportional reasoning all the time. So it goes, it's a math and science thing. So proportion is something that is one of those skills that everybody needs. So in math, we're teaching it, and it helps our science peeps out if we can help them with that. And think about it, if we can use the context of science to drive our instruction, it gives our kids something to hang their hat on. This is why they need to know the mathematics. So it helps our science peeps out. The graphics bring the problem to life. Jay, I think you're right as well. Anytime kids get to do something and move something and take an action, they're more likely to remember what they have done. Especially if they get hung up on a problem, they're more than likely to remember what they did in the context of this. Barry is right. Mathematics is the language of science. Love that. We need to, where's Barry? We need Barry up here. So any questions from the good of the whole, because we can throw this back to Mike at this point.
Yeah, and let's keep in mind there's some really good suggestions from all of you out there too. This was just kind of something
Absolutely.
we thought of as one of the possible things that we might need to review with students. Because someone brought up constant of proportionality, and so we might do a notice and wonder with a table and ask kids, who's recognizing when you multiply across the table, you're getting that constant of proportionality, which is also called a unit rate, right? So how do we find that out? How do we create that particular ratio that has that per one? Talk about those strategies, because people talked about, possibly, writing equivalent ratios and those sorts of stuff. It's all kind of a suggestion of where you might go. So we want to summarize this process, and then we want to turn it over to you to see what's coming up, and maybe we can use the 100+ people on this call to brainstorm some ideas. So one of the things we want you to think about when you're seeing students struggling with the grade level content is think about what are the prerequisite knowledge and skills they need to be successful. And once you have that, figure out how am I going to know if my kids have those skills, if they have that knowledge before I teach the lesson, because that's the ideal thing, right? We are all experts at doing things on the fly and answering those questions on the fly. But if we can set ourselves up with knowing that ahead of time, ahead of teaching a unit, then we can be much more prepared to support our students. And then we get some data on that. And then decide, so how am I going to adjust my instruction? I want to teach the grade level content, but maybe there's something I can do in a warm up, which was kind of our strategy that we shared with you tonight, to remind kids about this skill or refer back to this prerequisite knowledge. I'm thinking of everyone's great idea around just getting kids to look at a right triangle and identify hypotenuse and legs, right? That's a great kind of example of prerequisite knowledge to be able to work with Pythagorean theorem successfully. And so how might we do that? Is that an entire 5 to 7 minute warm up? Is that as you're getting ready to do a task, you might draw a right triangle and ask students to help you label the sides of it so they remember that vocabulary, they connect it to a picture before they start working with that context, right? These are all the great things about teaching and the professional decisions that you all have to make out of there every day.
Dan, can I
So that's
throw in
kind of
something
big
there?
picture. Go ahead.
Yeah, when you're saying the number two in your list, determine how you will evaluate if students have the knowledge and skills before the lesson. This is often what I don't see happening. Oftentimes, I see teachers assuming that students don't have it, so they do all of this review anyway because you're not taking the time to collect the data to even know if they need to provide that review or not. They're just assuming that they have to provide the review and they're spending that time doing it. And a lot less time would be spent if we collected that data up front to know I don't have to review all of these prerequisites when they only need this little piece of it. So I think following this process is really key in making sure we're spending our time wisely in front of our kids because we only have certain amount of time to spend in front of them and every moment is precious. So anytime we can streamline that, this is great. I think we need to make sure we adhere to that.
Yeah, and it made me think the other side of it too is how we try to teach a topic and then we kind of get frustrated and tired because kids are struggling with it because we haven't taken the time to see where they might have misconceptions and they might need more support. And so we kind of build in scaffolding or we do scaffolding that isn't necessary, or we try to revisit topics. We have to spend more time on it, and it's tiring for us to have to constantly do that. So if we plan wisely, like you're saying, right, we gather that information ahead of time, we make it easier on us because we can know ahead of time when we're going to need to support our students. So that's definitely something to think about. And Lynn asked a great question. Did you
Yeah,
see
I was
that?
going to say Lynn has an awesome question. Go ahead.
Yeah, so Lynn's question is, what happens when you have a third of your class that need the review and a third of your class doesn't, and the rest are kind of in between? So I think a lot of that comes down to maybe the strategies for how you review some of that content. So it seems like, 2/3 of your class are kind of need some support. And so you might do a warm up, but you might structure your warm up where kids who don't need the review are supporting kids who do need the review. You might do, and that's kind of, Sharon, what your suggestion, right? That strategic partnering or pairing. Um, I'm a big fan actually of random grouping, because we know that random grouping, builds community. We know that random grouping allows kids to recognize that they are all capable of doing the mathematics. And so you might, I think do that review anyway. If only a third of your class doesn't need that support, that's a big chunk of your class that does. So that might be something to definitely address. We've got some time, so actually, how about what are some topics that are coming up for all of you out there that students have struggled with in the past, and let's brainstorm some prerequisite knowledge and skills and think about how we might attack that particular topic.
Oh, Jim was
in there
quick.
quick.
It was like he was ready with that one to press send on it. Did you see that?
Mm-hmm. Mm-hmm.
Okay. So Tracy also said inequalities. Jim said systems of linear inequalities. Jim said fast typer. Kudos.
Yeah, so that's a good one. So let's see. So Mike, can we bring up like
Inverted
a whiteboard with some text capability? And let's do Jim's topic since he was in there. Doug's got a good one
And
too.
that will
Similar
kind of hit on
triangles.
Tracy's. And that would kind of hit on Tracy's as well.
Yeah, Tracy mentioned inequalities also.
Yeah.
All right, so Dan, I'm going to give you control, and you should be able to annotate on this whiteboard if you want.
All right, let's see. So I got to find a text tool, huh? All right, so here we've got system of inequalities. There's been a lot of suggestions in there, so hopefully I got that correct. Systems of linear inequalities. Yeah, let's make sure they're linear inequalities.
Yeah. Yes. Yes. So knowing that, what are some prerequisite knowledge or skills that you think that students would need to know to be able to be successful with this topic? All right, so what does it mean for something to be a solution to an inequality? So solutions,
To
knowing the
inequalities,
different
right?
inequality symbols, the symbols and what they mean, more than one solution, solving just a simple like linear inequality, like one. What is an inequality? Linear equations, being able to check the solution on a graph, graphing a point, why shading on a graph.
Yeah, so we got a lot of good things in there. Mike gave me control to type, but not the control to edit.
Make a list of possible solutions and discuss why there is more than one answer. So Linda is getting at what we could do to get at some of these. They need to know the alligator story.
So graphing inequality in two variables, things like knowing the symbols. We're getting at like some skills as well as some knowledge, right? Because
Right, getting at like
sure.
solving a simple linear inequality, like just being able to solve one.
Mhm.
Um,
Yeah. And we just have
a lot
ideas of
and
like graphing points, graphing lines,
graphing
like
points,
those sorts of things.
why shading on the graph,
Yeah.
going
Um,
back through.
yeah, there's actually a great I use this actually all the time with my teacher candidates. There's a great Nspire file about solving systems of linear inequalities where you move a point around and different parts of the plane light up. And we talk about, why does the line change from solid to dotted? Why is this region overlapped? Why is this one now overlap in terms of its shading as you change the inequality signs? There's a great series of questions in that activity that talks about, oh, what if I just increase my x point by 1? Is it still a true equation? Is it still a true equation? What if I keep doing that? When does it become false? When does it become true? Really, really good one. My teacher
Hey,
candidates
Dan,
start to understand why that works. Yeah,
how about this? Let me take control back from you for 1 second, and
sure.
we have a minute or two here. So why don't I share my screen, and then can you kind of walk me through where that file might be? So I'm on our website.
Sure.
Go under activities, right?
Yep. I think it's in Math Inspired.
Yes.
Yeah, I know which one you're talking about.
Algebra 2, I think.
Yeah, let's check it out. Systems of linear equations and inequalities.
Yes.
Yep. The one I was thinking of was in Algebra 1.
Moving a point
Well, there's
around.
one right there, Systems of Linear Inequalities 1 and 2.
Yeah, you're right. Maybe it is in Algebra 1.
Oh, there we go. Yeah, there's some.
Down at the very bottom, there's the two systems ones.
Is that the one you were thinking about, Dan?
It didn't look familiar, but I've
This
had it
one?
saved on my computer for a while, so.
Do you want me to toss things back to you and you could share it real quick?
I don't have it pulled up.
Okay,
But
no
yeah,
problem.
check under, it's either under Algebra 1 or Algebra 2. Doesn't look like it's Algebra 2. It might be Algebra 1.
May have it up. Exploring linear inequalities and moving the point around. Talking about whether the point's a solution.
Yeah, I think it might be, it's looking like the linear equalities in two variables.
Yeah, that's the one that tells you if it's true or false.
That's, yep, true or false, what it means. So this seems like a good, like,
There we go.
prerequisite topic in like what people mention of understanding whether or not it's true, false. Um, know if it's in a solution set or if it's not. And so this could be, a great like introduction to have students think about all those ideas around what it means to be a solution to a linear inequality. And then you dive into your lesson where you add a second line in there and ask students to now apply what they've just kind of remembered or maybe learned if they didn't get a chance to learn it before, um, to a new situation, which is
Nice.
really where students um, tend to remember things more, right? When they're applying it right away. So that's a good one.
I know we shared a lot tonight with Inspire, but I really don't want anyone to get the wrong idea. Like you have to use Inspire to assess this learning. it really is, whatever technology you have that you feel comfortable with that you think would help the students the most.
Yeah, Margaret square root table could definitely be done on an 84, right?
Sure.
Or it could just be done on the board.
Right. Low tech.
And
Yeah.
you can use the inequality app on the 84
Absolutely.
as you're exploring inequalities and systems of inequalities.
Yeah. So hopefully that was, is a helpful strategy for what we went through tonight in how to think about how to make small changes to your lessons in order to support students so that you're not, taking large chunks of time out of your curriculum, which we know you don't have enough time to finish anyway, and supporting students in a way that will give them opportunities for success, help them strengthen their background, and get that grade level content that they need, so they're not falling behind by spending all their time working on last year's stuff or the year before stuff. We need to expose them to more math.
Awesome. So I just posted in the chat window a link to our website, and let me share my screen so everyone can see that website real quick. So if you like what you saw tonight and it's something that you want to take more time and really kind of dive into, not just maybe just one topic that you maybe posted in the chat window and got lucky enough to explore tonight, but to really think about a lot of your content and your classes, feel free to visit our website to learn a little more about a new program that we created titled Accelerated Student Learning. And there's some good things to check out and read here. Again, if you're looking for more information, feel free to check out that website and reach out to us. As mentioned earlier, tonight we are giving away to one lucky winner a T-Cubed International Conference registration. This year, the T-Cubed International Conference will be virtual, and it is in late July. So our winner tonight is Elizabeth Ball. So Elizabeth, congratulations. We'll be in touch soon to give you more information about how to collect that free registration for the T-Cubed International Conference, but we hope to see Elizabeth as well as everyone else at the T-Cubed International Conference this summer. To receive a certificate of attendance, click the link in the chat window. Also listed as the link for the documents that we use tonight. And if you're watching this on demand, go ahead and copy that link to your favorite browser to receive your certificate. And if by any chance you're running into any issues with those links, just hang tight. You'll automatically get a follow-up email in a couple of days. And in that follow-up email will contain links to the recording, the documents, and the certificate as well. If you have any non-accelerated student learning specific questions, feel free to reach out to us. Or even if you do have accelerated student learning questions, either way, 1-800-TI-CARES, or reach out to us over email, ti-cares@ti.com. We'd love to hear from you. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future webinars, so please think about what you might want to see in the future and let us know. Huge thanks to Dan and Margaret and Sherry for all the time they put into getting everything ready for tonight. So thanks so much for all your hard work, guys.
Thanks.
And thanks to everyone for joining us tonight. We hope to see you back online next week. Have a great night, everyone. Stay safe.